A dash B1 dash is true length. If you want to use P dash Q1 dash, you can also use that. If you want to use 1 dash 2 1 dash, you can use that also. Over here on the HP side, horizontal plane side, which line shows the true length? The red line. A B1 shows the true length. That's written over here like this. What is the angle of true length with horizontal plane? Angle of true length A B1 1. The angle with the true length A B1 1 is denoted as alpha. If you see the angle over here with the vertical plane, it is called A dash B1 dash 1 dash, called as beta 1. If you see the angle of front view with the XY line, angle of the front view with the XY line, XY line is this, angle of front view will be located over here in the vertical plane, and it is denoted by sigma like this. This is the angle with the front view in respect to the XY line. If we see the angle of top view with XY line is denoted like this. This is top view, this is our top view, this is our XY line. In respect to that, the top view is making angle as sigma 1. Now, position of A and position of B, it determines according to the projections of point. Positions of A might be given as 20 mm above HP, 50 mm in front of VP. That's how the A and A dash has been located. Similarly, B and B dash may be located like the same only. What is distance between two projectors? The last one, what is distance between two projectors? The distance between A dash B dash or AB is called as distance between two projectors, which means that the total linear length between the A dash B dash or AB. If we rotate the true length, we can get the top view component, but if we want to have the rotated top view, then we can achieve true length. Now in the next portion we will see the specially customized animation videos made by the Cognifront software for the use of the GTU students exclusively. In the next part we will see the further solutions.
Click on the different tiles to access the examples. Draw the projections of the following points on a common reference line. Take 30 mm distance between the projectors. A. 35 mm above the HP and 25 mm in front of the VP. B. 40 mm below the HP and 15 mm behind the VP. C. 50 mm above the HP and 25 mm behind the VP. D. 20 mm below the HP and 30 mm in front of the VP. E. 30 mm behind the VP and on the HP. F. In both HP and VP. Draw the reference line XY. Since it is given the distance between the projectors is 30 mm, we have to draw each projection 30 mm apart. Point A is above HP and front of VP. Hence, it is in first quadrant. We have to mark front view above XY line and top view below XY line. Mark front view A' above XY line at a distance of 35 mm and draw a perpendicular line projector to XY line, and mark top view A below XY line at a distance of 25 mm. Mark the dimensions for both points on any one side. Point B is below HP and behind VP. Hence, it is in third quadrant. We have to mark top view above XY line and front view below XY line. Mark top view B above XY line at a distance of 15 mm and draw a perpendicular line projector to XY line, and mark front view B' below XY line at a distance of 40 mm. Mark the dimensions for both points on any one side. Point C is above HP and behind VP. Hence, it is in second quadrant. We have to mark both top and front view above XY line. Mark front view C' above XY line at a distance of 50 mm and draw a perpendicular line projector to XY line, and mark top view C on the same projector line at a distance of 25 mm above XY. Mark the dimensions for both points on any one side. Point D is below HP and in front of VP. Hence, it is in fourth quadrant. We have to mark both top and front view below XY line. Mark top view D below XY line at a distance of 30 mm and draw a perpendicular line projector to XY line, and mark front view D' on the same projector line at a distance of 20 mm below XY line. Mark the dimensions for both points on any one side. Point E is behind VP and on HP. Hence, it is in second or third quadrant. Since it is lying on HP, the front view will be on XY line. Mark front view E' on the XY line, draw a perpendicular line projector above the XY line. Mark top view E above XY line at a distance of 30 mm on the same projector line. Mark the dimensions on any one side. Point F is in both HP and VP. Hence, it is in all the quadrant intersection. We have to mark both front view F' and top view F on the XY line itself.
If you see the projections of point, the projections of point is very much important role in the projections of line. If you see in the problem, that you will see some of the very basic fundamentals given over here. If you see in the problem, above HP means that above XY line. Below HP means that any object would be below XY line. Very simple logic. If you don't consider this kind of quadrant, if you do not get better idea in the quadrant system, just remember very simple logic. If anyone says that a point A is 20 mm above HP, over here it is given 35 mm above HP. Above HP means that it is above XY line. Mark a point 35 mm above XY line. What else this point says? 25 mm in front of VP. In the same direction, in the same path, you will have 25 mm in front of VP. In front of VP means that your point would be on the below side of XY line. In front of VP means below XY line. Mark a point 25 mm away from the XY line and give the dimension. One more very important thing, if you see in the problem, it has been given that take 30 mm distance between the projector, which means that distance between point A and point number B should be 30 mm. We have achieved the point number A. Now when we are starting the point number B, it should be exactly 30 mm away from the point number A on the XY line. Very simple logic for projections of point. If it says above HP, above XY line, below HP says below XY line. If it says in front of VP, means that it is below XY line. If it is say behind VP, it comes above XY line. But any of the time it says that in HP or in VP, which means that that point will be considered on the XY line itself. Now we will see the further solution on the same.
Thus, the projection of points were drawn as per the given conditions on the common XY line by keeping distance between the projections as 30 mm.
Welcome. In this session, we are going to study the projections of a straight line. A straight line is a one-dimensional element connecting two points by the shortest distance, and the length is always a true length TL. The projection of a line can be obtained by drawing the projections of its endpoints on different planes. So, let's start. A straight line AB is perpendicular to HP and parallel to VP, where the point A is H units above HP and point B is D units in front of VP. Observe the front view of line AB as line A-B'. As you can see from top, point B is visible and it hides point A. So, projectors from point B passing through A meets HP at point BA, which is the top view. So, Let's see how it will appear on paper. For this, first draw a horizontal reference line XY. Then draw a line A-B- above and perpendicular to XY with endpoint A- at a distance of h units from XY. Next, mark a point BA below XY at a distance of d units in line with line A-B'. Line A-B' and point BA are the projections of the line AB on BP and HP respectively. Now let us take another case. A line AB is inclined to HP at an angle theta and parallel to VP at a distance of d units. Point A is h1 units above HP while the point B is h2 units above HP. Well, look at the diagram carefully. The projection of line AB onto BP and HP is line A-B' as the front view and line AB as the top view respectively. Alright, now we'll perform the steps for drawing these projections on the paper. Draw horizontal line XY as a reference line. Then locate point A' at a distance of h1 units above line XY. From point A', making an angle theta with HP, draw a line of length equal to AB. Locate the other point B'. So, line A', B' will be the front view of line AB. Now, change the position of the observer. Looking from the top view, the projectors are passing through A and B and meet the HP orthogonally at points A and B. The line AB is the top view of line AB. The length